Okay, this is example number 3 of photoelectric effect. So in this one, they have given there is ultraviolet light of wavelength 280 nanometer. Okay, so since they have given wavelength, we can find the energy. Energy is Sc by lambda, or you can use this formula also. It is a given nanometer, so 1240 by 280 electron volt. So basically, they are giving the value of energy of incident radiation. Okay, so this energy is now used in an experiment on photoelectric effect on lithium of, I think they are telling this work function is W. Okay, anyhow, you have to find the maximum kinetic energy of photoelectrons. Okay, now in this question they should have they should have mentioned that this work function is 2.5 electron volt, which was a misprint here. So work function is actually given here. So they are asking the maximum kinetic energy of photoelectrons. So we are going to use the formula that energy incident gets converted into work function and kinetic energy, or kinetic energy is energy which is incident minus work function. Okay, so for this we have calculated the value of energy which is incident, that is 1240 divided by 280 electron volts. Okay, minus work function. Work function is 2.5 electron volt. So just solve this equation, 1240 divided by 280 minus 2.5. So you will get the answer as 1.9 electron volt. So this will be the maximum kinetic energy of photoelectrons. The second part is, what is the stopping potential? Okay. So for stopping potential, we know this relation, that E into charge of electron into stopping potential is equal to maximum kinetic energy, and that maximum kinetic energy we have just found as 1.9 electron volt. Okay, so that is equals to charge of electron E into stopping potential. So E will get cancelled from both sides, so you'll get stopping potential as 1.9 volt. Okay, so let's move to the next one. Okay, in this one they have given that collector plate is at 2 volt with respect to emitter plate. Okay, so this will be, let's say, emitter plate, this is collector plate. Okay, and collector plate is at 2 volt. Okay, so this is a battery which is having a potential 2 volt. They have given that work function of the copper, work function is 4.5 electron volts. The emitter is illuminated by a source of monochromatic light of wavelength. So they have basically given you energy formula 1240 divided by lambda in electron volts. So that is 1240 divided by 200 electron volts. So they have given you the value of incident energy, work function they have given, and they're asking you to find the minimum and maximum kinetic energy of photoelectrons. Okay. So to calculate maximum kinetic energy, we are just going to use this formula, max that maximum kinetic energy is energy incident minus work function. So energy incident value we have already found, 1240 divided by 200, work function they had given. So just solve this one and you will get that maximum kinetic energy is equal to 1.7 electron volt. Okay. And after this is actually the maximum kinetic energy of electron or photoelectron which just came out. This is the maximum kinetic energy of photoelectron which just came out of the metallic surface. That is 1.7 electron volt. But according to our given configuration, this was emitter plate, this was collector plate, and this was at higher potential. Okay. So this will be your positive plate, this will be negative plate, and direction of electric field will be like this. So if an electron comes out, force on an electron will be along this direction. So actually it will start accelerating from here to here. So when it just came out, its maximum kinetic energy was 1.7 electron volt, and this battery is also 2 volt. So from here to here, it will gain energy, that is potential energy equals to charge into potential, that is 2 volt. So when this electron reaches at this point, its total energy or total kinetic energy will become 1.7 electron volt plus 2 volt. So that will be 3.7 electron volt. Okay. Next is we are supposed to find the minimum kinetic energy. Okay. The minimum kinetic energy will be when this electron, which is just able to come out. Okay. If the electron is just able to come out, its energy, kinetic energy will be zero. So when it reaches this collector plate, it will have gained an energy equal to 2 volt. So that will give you the minimum kinetic energy. That will be 2 electron volt, and maximum kinetic energy will be 3.7 electron volt. Thank you.